you
No, thank you.
talking to us. Okay.
Thank you so much. And Dan, thank you so much for coordinating this. And Maria, it's just been a pleasure working with you this year, and I've learned so much. Just a brief background on myself. I've spent my entire career in technology and launching new technology products to market, very specifically what I call disruptive tech, right? So anytime you have a change in how we're doing things, it's very hard to get early adopters into that. So I've been through 3 disruptive tech cycles. I launched Borsetta after I read an article called The Trust Machine from The Economist, which really talked about the blockchain and just how we would be moving to a system of trust because we don't trust anything anymore, right? And so with that, we started securing high value assets on the blockchain. And then we knew that everything was moving to chips and sensors, right? And the concern is, how is our data going to be secure and trusted? And we designed a very sophisticated AI chip for the US Air Force that I can get into later. And now we have spent the last year very focused on the energy grid, right? And the concern is, we don't have the blockchain, we don't have the crypto, we don't have anything, we don't have power. And you know, we need to move to a decentralized you know, energy of resources. And that's been our area of focus. And what I'll start with is just, I'm going to talk on some topics and I'm going to distill them down and hopefully remove some of the, demystify them, I guess, in a way that people can understand. So I think we know the problem right now that we're facing, right? We have billions and billions of devices that are being deployed. I think we'll have 100 billion. We'll have 100 hyper-connected devices to each of us by the year 2035, right? And because we're accelerating, we've got 5G coming, we've got 100 times network capability that's going, in essence, to the chip level, right? And to the data level. And then we know we have 50% here in this country of our devices have already been compromised, right? And we know that, you know, 80% of chips are produced outside the United States. So we're pushing all this data to these really smart chips, right? That are going to be embedded in our everyday life. And we have no trust. So that's really what brings us to the blockchain, right? So the blockchain, actually, the very first block that was demonstrated was back in the 90s by Dr. Stuart Huber. And he was the first to have a cryptography, a way to cryptographically encapsulate data in a block. But the problem was our computers weren't fast enough, right? And so now that we have accelerated speed, and that's brought on Satoshi's white paper, where he envisioned this, you know, great world where we could have money, but not centrally controlled money. And then in 2014 was really blockchain 2.0, which we had a way to transfer money using the blockchain, right? A store value. And then in 2014, Ethereum launched. And that was the first time we could have smart contracts that could execute applications, right? And so we've really had a framework for the blockchain since 2014, but a lot of people are just hearing about it and they don't understand it. And it's really going to be the foundation of our future, because we have to create systems, especially in our energy environment, that we don't trust anyone, right? We need to assume no one is trusted, and we always verify. And so that's kind of just the premise of we have to decentralize our data, right? We have to decentralize our identity, so my personal information is not exposed. And to do that, we need to expand on whether it's a public ledger or private, it's a living ledger, right? So that's kind of just foundation. Now, you're probably hearing a lot about this Web3 world. Everyone's like, what is this Web3 world, right? And the metaverse, and, you know, Facebook hijacks everything, right? So the Web3 world is really, we're fusing our physical world into the digital world, right? And so we've talked a lot about digital twins in the past, where you have a replica of your system. But now with the blockchain as a framework, you can actually connect our physical and digital world in a way that can create privacy and trust. And there's no central control of that, right? So that's some very interesting things now that we are able to create what I call intelligent digital twins. So that they inherently know who they are, right? Who owns them, who's provisioned to have access to them. And that's really how we need to look at our systems as we deploy renewable energy assets into the market, that it's never trust, always verify, right? Is the premise. So then I want to just touch upon sort of these future energy models that with this convergence of AI, of quantum computing, of distributed energy assets, right? How do we create an adaptive, flexible grid? So when we look at, we have these billions of endpoints that we're now deploying, right? We need to have, again, a zero trust chain of custody, right? Where did those, where were they born, right? And we have the chain of custody knowing where that chip or where that drone or sensor was born, what components it's put in. It has its own unique identity of all the components that reside in that, right? We then look at these microgrid assets that we are deploying need to, again, be intelligent twins, and they need to be tokenized. And what that means is all tokenization is, for example, I want to give you my phone number, but I don't want you to know what my phone number is, right? So we can wrap, a wrapper around my phone number, and you get a call from me and know it's me without knowing my phone number, right? So we want to ensure that our data is encrypted, it's not hijacked, right? And that's, again, our problem today is that our data has been exposed, and we need to ensure we're using encryption methods that we can make transactions and do it in a trusted way without knowing the data, right? We understand the aggregate data, we can learn from the aggregate data, but not necessarily what my phone number is. And then the other problem on this third part here is the future regulations, right? We know we have regulations that are pushing down right now. We have to have made in America. We have to have, additional cybersecurity, and we're dealing with cybersecurity at the server level, right? And we're trying to put Band-Aids on all of these, security problems that typically come through because a human allowed that particular person to come through and didn't know it, right? So how can we push down, further down in the supply chain, that not only the chip's compliant, but that inverter is compliant, right? Because not only the encryption that it's doing, but let's say the AI models that it's running are using a federated learning model that doesn't allow for others to extract the data. My model is kept private and proprietary, but we can still learn on it. So we want to try to push down more of this capability to the individual asset, right? The inverter itself or the smart meter, versus the data going back, because the data is not going back. The decision is made at the smart meter itself, right? Because it's got more intelligence. So that's where I see some of these future models. Now, this is quite complex, but this is just, again, very high level. What I want to share is that this is really the future of what I call adaptive change. Everyone talks about climate change. I like to kind of take it out of being politicized and say it's adaptive change, right? We have to create these systems and deploy systems that are going to rapidly deploy renewable energy assets in an intelligent way, but it all has to be based on zero trust, right? That, again, never trust, always verify. So every component that we start deploying out to the market needs to be designed with that framework, right? And so as we're adding quantum computing and processing, we know, there's encryption, problems that once quantum compute becomes more accessible, that our current authentication could be corrupt on these devices. So we need to look big picture as how that technology will impact these intelligent digital twins that we're deploying. We need to make sure we have a mesh network that, again, if this microgrid needs to shut down, that it can obtain communications from other grids that have been shut down in a way that's safe and trusted. To the ecosystem, we want to create a platform for great companies to onboard new technologies and to deploy applications that can enhance and create a more adaptive energy grid. So now I want to take us into like real life, right? So we talked about all of these concepts, and now I'm going to give you another buzzword that we've covered blockchain, we covered AI, we've covered quantum computing, and now we're covering NFTs. Okay, and so what we'll go into a little bit deeper dive, but what we want to do is deploy the first NFT microgrid, right? That's deployed. We're targeting a tribal nation community here in the United States to deploy this entire, from birth to deployment of these assets, right? And what does that look like? So what is an NFT, right? This is, highly controversial. It's a crazy place right now. And what an NFT is, the concept around it, right, is around scarcity. It's around a unique identifier to a particular either digital or physical asset, right? So what's happening today is a lot of people are paying crazy money for really just a JPEG, right, of an image, right, that they can put in their digital wallet, right? But the future is connecting our physical world with a unique identifier. And when you tokenize it, right, it's part of this Web3 world, which says, okay, this physical microgrid has 6,000 components, right? We can tokenize those. And in essence, we have a form of money, right, that we can assign to those physical assets digitally, right? So think about it. It's everything from the IP, from the patents that Maria has developed for MIT and has participated in. Those are intangible assets today. So on a company's ledger, right, we're just creating a third ledger that's alive, that's living. It says, okay, what is the value of that patent, right? And now we can digitize the value of that. We can assign a token to that. And that token can say, well, what's the price of the IP, right? Well, I want 1 cent for every time something's transacted, right? So there's no one, going to the company a year later saying, how much did you sell, right? Real time to have access to that IP, that company is paying real time for that royalty or license of that IP. The same with the grid, right? So now we have a digital copy of this grid. Let's say, I'm gonna go through here. So this is how we're going to digitize and create an NFT. Okay, so we have an asset registry on the blockchain. And all the components, let's say it's from Siemens, right, that we are, tokenizing, right? So we title the assets, we ensure that they own the IP, we validated the IP, that they're owners of that, right? And that all of those components reside in Siemens digital wallet, right? So they can see in there, okay, I have $6 million of assets that we are going to tokenize. Now I have a token, an NFT, that it's a unique token for these particular assets that will be deployed on this tribal nation project, okay? So now what happens is we want to demonstrate to the DOE, to the national grid, our energy grid, is how this process goes from the actual digitization of that token and how it goes through the supply chain for these tribal nation companies. So here's an example of, so Borsetta has a patented process on how we tokenize assets. So for example, we want to make microgrids bankable, right? How do we do that, right? There's an average cost of a commercial microgrid is, let's say, $4 million, right? So we tokenize the assets, they go through our platform, right? Again, Siemens owns those, and we create digital tokens that are assigned to those components. And what happens is you can either pay for those components by traditional money, right? We have a, you know, an ACH goes to your bank account or can go through Visa, MasterCard, whatever payment system that's not on the blockchain, right? So we have a traditional hybrid if people just want to pay that way. But what's kind of happening in the background that you don't see is that we have this digitized economy of those assets that can now be funded. So think about companies that have stock, right? We could issue 100,000 tokens. It's just like stock. And I can say, well, I only have $100, but I can own a fraction of this project, right? So today I don't have $4 million, but I want to help participate, right? And I can put in $100 and own a fraction of this project. And you can't do that today. In today's world, right? Everything is paper-based, everything is project-based, right? Everything is investor-based, that it precludes you and I from participating. And that's really the value, is opening up the opportunity for more people to fund these types of projects. And so here's the steps that we go through. So step one is we have title chain, we originate the assets, we verify and validate them. We have what's called an oracle. So off-chain data, we validate that IP. There's a score for it. They have 170 million patents around the world that can validate, right? So you are the true owner, right? You have an NFT for your work, your craft, your whatever is uniquely yours, right? So we're partnering up with Cymani, and they are the Cyber Manufacturing Institute. They are funded and stood up by the DOE. They work with, Maria, you know, they work with Idaho Research Labs. They are also part of University of Texas, San Antonio. So they're going to be our security validator node, right? So now we secure the assets. We say they are what they are. Cymani then does a cybersecurity score, right? Based on whatever government kind of requirements that grid inverter, for example, has. And this is, again, it's all done on the blockchain. It's all validated. So we have this chain of custody that is immutable, can't be altered, can't be changed. TRC, as you know, or any of you know, they're a large global engineering company. They deploy, you know, large engineering, you know, substations to nuclear stations. They are the project lead, right? Project management that says, here's the best location for this microgrid on this tribal nation community, and define out the scope of it, right? So we say this $4 million project has these components. We then simulate it with a company called Zendi, which is they have a modeling and simulation platform that takes the assets, actually simulates them in the environment before it's even been deployed. And they run all sorts of financial calculations of potentially how much revenue those assets could generate, how much energy could go back to maybe a balancing agency, how much those investors can expect to return. But the really fascinating thing here, and this is what's super hard for people to understand, is that for the very first time, these tribal nation communities will have their own wallet, right? So when we write the smart contracts that say this $4 million grid, the contract can be written that the tribal nations owns all of those assets, right? Owns 80% of the revenues, right? And that there is no centrally controlled system holding their money, right? They get paid immediately. So it's a very interesting opportunity for us to create trust. Unfortunately, you know, we still have, I think it's the Navajo Nation community, still 25% of that community has no electricity in this country. And it's just unfathomable that, you know, that happens. So we really want to lead with a project that demonstrates to this country that we can have a trusted system, but we have to use this framework, right, to ensure that it's really software is making this decision. Software is executing the code versus a centrally controlled system today. And so this is just, you know, I know I've covered a lot here and I want to be sensitive to everyone's time. But this is what we've been, you know, presenting to the DOE, and we've been active in trying to show how these smart contracts will execute, right? You have requirements, you know, legally, we've got a lot of tariff issues. There's a lot of things that, that come into play, but how do we do this in a way that it's trusted, but also that we are able to rapidly deploy renewable energy assets throughout our country. And and how do we do it where we can accelerate it while we're ensuring a secure environment and trusted environment? And this just kind of gets a little too deep, and I'm happy offline to share this with other people. But this is just like the new financing flow. If you look at, you're digitizing physical, you know, grid assets, you have to title them, you know, you have to custody them digitally, right? You have to create the smart contracts on how the power is going to be shared or pricing, right? This is eventually everything will go through this process, right? Pricing, monetization of those assets, loan and funding of those assets, right? And, you know, who's on the revenue generating side, right, of those. Our platform is, we're built on the consensus platform, which, as I mentioned back a bit ago, Ethereum is probably 70 or 80% of all the smart contracts executed today are on Ethereum. We are blockchain agnostic, so we can use Hyperledger. There's a variety of different blockchain platforms. We're on consensus just because they are doing, we have the ability to scale transactions. I think yesterday Polygon did 460,000 transactions a second. So the system is scaling now. And that was a concern before. It took 10 minutes to get a Bitcoin validated. But, and this is our smart asset management platform that we leverage. And this is where I'll just end, is that, you know, the value that we bring to the energy grid, right? The value that this, you know, revolutionary technology brings is that we can securitize assets in a new way, and we can get funding for those assets in a new way, and we can create this peer-to-peer energy economy, and hopefully rapidly deploy renewable assets in a way that the government will help us do that, because we're proven that we know at the component level who owns it, is it trusted, right? And we know before it gets deployed how much potential revenue, right? Is that the right location for those EV battery stations? Is that the right location for this community microgrid for this school, right? And is it the right component mix? And that there's a new way of having all Americans potentially participate in funding these that doesn't exist today, if that makes sense. So that was a mouthful. But I'm happy to answer any questions. I know we covered a lot. We covered Web3, we covered blockchain, we covered NFTs, and it's like overwhelming because it's really a, you know, we are transitioning to a new world where the internet, so if you think about the internet, initially the internet, we uploaded documents, right? That's Web 1. Web 2 is the internet. We then started sharing, right? We had commerce, we had smartphones, we had social media, right? But it was very centrally controlled. We know that internet today is centrally controlled by a few companies. Web 3 is user controlled. Is you and I, whether I have unique IP or I have content, or I want to participate and own a smart grid, right? It's user control driven and money's embedded in it, right? Money right now is on the outside, centrally controlled. Now you have smart contracts that you can embed money and have those assets transact, if that makes sense. It's like my only way of like trying to tell people that money's really embedded now in the internet, and we don't have traditional centrally controlled entities, managing and running that. And that's why there's a concern with most governments because they want to control it.
Thank you very much, Pamela. A lot of people connected late because we had a link problem. So we have quite a bit of time for discussions, for questions. I have to say that for me personally, I've been talking to Pamela now for a while through our grid formers community, and actually it still remains mind twisting. Maybe I'm slowing down as being old, but there are all sorts of questions. And so rather than me starting, please make sure that you put your questions in the chat or just raise the hand, and let's make it informal. But I think that we could start here with Dan Wu. He has a question. Then you want to just raise the question, or you want to read it, or?
Yes, so Dan's asking about the total number of Bitcoin is limited. Yeah, it's limited to 21 million. So you can never create more than 21 million of those coins. People can always divide one Bitcoin into fractions and fractions, which is true. So like you could go and get your wallet set up today and you could spend $5 and own a fraction of Bitcoin with $5 US. So what it means is, if this is my just personal feeling, is that if you own any Bitcoin, you will be a bank of the future, right? So we will peg physical assets to whether it's the US dollar or Bitcoin. And because it's a scarcity, it's limited. And you're able to run smart contracts with it, the demand is going to increase, right? Because there's limited supply. So the value of Bitcoin will go up over time. But I don't get rid of any of mine. I never will. I'll loan out mine as a bank in the future for people that need it. But that's the interesting value, is you can own a fraction, of, and it's a very hard concept for people to understand, but it's really just a store of value. And now that we can assign a value of physical assets, you will have such a limited supply. I would rather just hold that and have it work for me, whether I'm getting interest on it, because I can get interest on it today. And unfortunately, what's happening with the dollar, you can't. And with inflation, it's a hard thing. So did that answer that question? I know that's the fractional one's very hard for people to comprehend.
Okay, so maybe, thank you, Pamela, thank you, Dan. So let me try something. You said at one point, Pamela, that let's think about, there are a lot of people here who do power systems, microgrids on the call. And so you said you have a microgrid as a system, right? Mm-hmm. And there are components. And now somebody wants to buy components, convert them into these non-fungible tokens. Yep. I have still to see sort of, there is no unique way of assigning the value of a component within a system independent from what system it is connected to. So, for example, let's say demand response or ADC technology that you're familiar with and so forth. It has a value to the customer, but it depends on what is the price of electricity from the outside. It depends on what are the other resources and so forth. So how do we deal with the question of taking a system and assigning the value to components and selling them?
Mm-hmm. Yeah.
Does that make sense, the question?
Yeah. So that's why our pilot project is really critical, because we want to demonstrate. We have 8 companies in the ecosystem, right, of this project. So we have a law firm that specializes in legal issues around energy pricing and tariffs and all of that, right? So we want to demonstrate the components that have been decided to be deployed to that particular location, right, in that reservation. We identify those assets, right? All of those assets. We can go down, you know, to 5,000 components, let's say, that make up that grid inverter, right? We're using AI to ingest all of that data. So you now have this entire chain of custody for those assets that you want to secure, right? You want to sell. You now have a digital twin of it, a real life digital twin that most likely what you're talking about, those systems will have intelligence, right? It will be some sort of smart meter. So there's going to be something that is, you know, determining power, voltage, velocity, all of that, right? So that's where you now have the ability to write smart contracts to how much money that component, we've tokenized 5,000 pieces, right? Whatever it is, right? We have one NFT. All of us here on this call are all investors, right? In that one NFT that we're going to own a fraction of it, okay? And we have a smart contract that will execute to say, how do we all get paid? Who gets paid, right? And all of us here today have a digital wallet. We're in this project. So there's no question that this $4 million grid, let's say the US government LPO office gave us a loan, right? So part of our money goes back to pay for the loan, but we are all participants, right? Now, who's setting the price, right? So that's where we're kind of getting into. If my microgrid is sending energy back to the balancing agency, who's determining that price? What type of power is it, right? So we're getting into some obviously very, revolutionary changes, right? Because it's like, can I be my own power provider, right? Can I set my own prices to the other, community next to me because they need power that I'm generating? And we can demonstrate that on a tribal nation because they're their own government. And that's actually why we want to demonstrate there, because we don't have a lot of the requirements right now from the US, right, regulation. So we want to showcase, here's how smart contracts will be written. Here's how we can validate, right, price. Here's how this peer-to-peer energy, transaction can take place in a trusted way. And that's why you all are so necessary, because we're really leading a completely new market, right? And it's,
just to sharpen my question, I think it really is an important one, and we are trying, as we all know, you are talking blockchains, I'm talking inverters. So right. How do we put it all together? So the question really at the end is that there is an open research question of, do we arrive at these prices, at this valuation just through consensus, or we can support it? And we've talked a lot in these grid former gatherings about, I can actually simulate, starting from physics, I can simulate and emulate what that particular solar panel can do to the whole neighborhood or to the next neighborhood. And based on these model-based assessments of potential value of subsystems, you can actually still still connect consensus building with real physical value or economic value of the components. Do you agree that that is really an open research problem that I don't think very many people are looking into it? Because if you just look at it as blockchain, it's not going to solve, or if it's just a law case, it's not going to solve it.
Right. No, and I absolutely agree. The modeling and simulation is critical, right? Because that will determine the smart contracts that then get executed, right? Because if you can't model and simulate the potential of this grid, group, I mean, the consensus can happen, right? That's like you have nodes that can validate the data. But what's not known is the propensity of what revenue that will generate, how, and it's dynamic. So you have, like with your diamonds, you have dynamic pricing, right? That can also, time of day, right? You can embed all those types of algorithms to say this smart contract will execute when it's this time of day, right? It's this price, right? So you have the ability real time, because the asset inherently knows who it is and who owns it and who receives revenue from that, right? And
so to sharpen it, then we actually have these participants in purchasing non-fungible tokens, and they gather information from the rest of the grid or from the rest of the system to simulate potential value or potential ability to participate. So a lot of intelligence is actually embedded into these components, right?
Right.
And so is there still, in your mind, is there still need for some minimal coordination, or it's all peer-to-peer?
I think there's a need for coordination, right? Because like when you think about kind of like the stock market today, and even the crypto market, right? There's a ton of modeling and simulation that's being done on predicting price, right? On the value of understanding the dynamics. If we add 10 more microgrids to this community, what's the potential revenue, right? What are the potential implications if we don't have enough power? So I believe that we need to do more research, right? That's why we've been working so hard to get our projects going, because the energy, they need to look at sort of this new world as being like what's happening with the stock market, right? What's happening with the trading of assets right now, which are digital assets, which are, stocks, bonds, commodities, all of that's moving there, right? So energy will be a part of it, right? In the future, we need to help sort of drive it from the perspective of, I believe, user control, right? And that, participants like all of us here on this call can participate in funding these microgrids, right? But we still need to have, big picture modeling simulation of how do we get that balance, which is, what so well is like, how do we create balance between those agencies? How do we know what's behind the meter, right? If we have a distributed, registry for everyone with all of their, smart devices that are going to have some sort of energy producing capability, we should be able to aggregate everyone's devices in the future and leverage that power, right? So
I should not take time, to just ask my questions, but is there anybody else who wants to comment or have some questions, please? Okay, so then I'll keep going. So the thing that you talk about at the very beginning about making sure that you have basically self-security, everything encrypted in the communications with the rest of the system. So that is, can you just now, in context of this project that you have, say, is that roughly, what are the likely variables that need to be encrypted to be exchanged, like price of electricity peer-to-peer, or power or rate of power at which you can you can exchange, provide power or consume, or so not everything has to be encrypted, right?
Right, exactly. And what's interesting with a lot of these new intelligent chips, right? We have the ability to embed hundreds of millions of ledgers, right? We just, again, you think of a ledger, it's just like debit credit today. We have a static debit credit. Well, if you think about, we can create compartments in the chip, the sensor itself, that's sensoring voltage, power, control, right? That they can all have their own ledger, and that ledger can be one ledger could, you know, I don't want to see what your power model is, right, versus the other person. So we want to ensure that those models are kept encrypted, but there's the main ledger, which is the aggregate data, right, is that everyone gets to learn from. So you have the ability to partition at the sensor or at the inverter level. And that's where we want to drive the security versus, again, going back to the cloud and trying to, once, you know, the device gets information back to the cloud, trying to then, you know.
Yeah, I was just going to ask about that sort of comparison between what you're envisioning and just basically sort of some sort of secured cloud, you know, end-to-end cloud computer platforms that a lot of people are pushing. So can you overlay on the cloud communications, you know, your cyber secure consensus building?
Yes, and that's where we want to drive that security at the device level, right? So what's happening is, as these devices are more intelligent and doing autonomous things, we want to make sure they don't go bad, right? And just like the conversation we had with Virginia is, how can we, you know, potentially, if a device itself goes bad, how do we, as another device that's learning from that, right, that's doing things, how do we not get bad information, that second device, right? And so that's where being able to have a unique identifier, right? This has a unique non-fungible token assigned. It's almost like it inherently knows, like we all know who we are, we have unique DNA, right? So sometimes we know who we are. We want each device, right, to have that unique identity and ownership and knowledge, right? And then you can partition down, well, I'm only going to show my phone number, or I'm only going to show, you know, this price, right? These other pricing models are proprietary. You're not going to see them, right? And so you want to do it at, you know, with a secure cloud encryption, you want to do it at the device itself versus that data going up and then sharing that data, right?
So I want to actually put, I think Hilu is gone, but I want to put maybe Ning Lu on the spot to tell me if I am completely out to lunch, that most of the models that we are using now in power systems, they actually don't lend themselves to such distributed implementations. Ning Lu, Pamela is from North Carolina State, leading researcher in this area. So, and anybody else who wants to pitch in, the models that we use now for energy modeling, energy management systems, from top-down control for hierarchical control, they sort of require full information about everything, right? And that is information about the grid, information about the large conventional power plants, and you assume that load is something historic. So everything that you are talking about is just not even observable to these models. So Ning Lu, we are working at MIT, and I see at least a couple of people from our group, Dan Wu and Dr. Rupamati Jadivada, who have spent, I don't want to admit how much time, actually trying to formalize this method, this modeling, which is interactive, distributed, to support the type of stuff that you are talking about, so that we can connect it with the computing and the security. But Ning Lu, I don't want to go out and just claim just for myself, because I may be biased, that most of the models that we use in power systems would not lend themselves to implementation that Pamela is talking about. Can you say a few words on that?
Yeah, I think what I can add to this is, hi, how are you? In Power Grid, I think I didn't really fully get what Maria meant, but
sorry, maybe I can just repeat. What I meant was like modeling that we use for transient stability, for power flow and so forth. They assume, you start running this software, assumes that the whole information is available in the central level so that you decide how much to schedule to balance.
Oh, yeah. This definitely.
And I think that for scheduling in particular, and I think what Pamela is talking about is completely different world that we've been dancing around. You mentioned, Pamela, earlier on the Gridwise Alliance. I've followed them for a while, but these people are talking the architectures. And our modeling that we teach in the classroom doesn't lend itself to that type of architecture. So, Ninglu, just to double check my sanity, I just want to see what do you think?
I think you're completely right. I think we're doing several control mechanisms for microgrid. I think from my perspective, the difficulty to implement that is, first of all, in microgrid control, you don't really get complete information. Because microgrid control usually are executed in abnormal system conditions, meaning you probably have a prolonged microgrid operation because there's a outage outside. So your communication are harmed. So you would basically just have control with reduced observability of the system. Even in the optimal condition where you have normal grid operating, and then you're just basically doing a more or less demand response in response to price or whatever, your information to your device, who's contributing, who's not contributing, is more or less hard, because one of the things that we have difficulty with is to assign benefit, and then also assign credibility, like who contributed the most for doing this control. And then we found it's very hard, even technically, you know exactly who's doing what, to say whose contribution is crucial for doing that. So I think this is the main issue when you have a digital token where you have very clear ownership, even though, but for your piece of device, exactly how much you contributed to each operation is blurred. So in that way, you want to have this, say you gained like $1,000, and then you have 10 stakeholders holding device, then who's going to get how much? Are you going to evenly distribute them, or you're doing that by performance? If you're doing it by performance, then how do you actually quantify the performance of them? Right. So I think those are the difficulties, but I'm not saying this is not entirely impossible.
No, I know. And that's why we need you all, because you understand the dynamics of it. These smart contracts will be executed, right? And we need a modeling and simulation environment because you inherently know the problems with the system, right? And so we have to be able to model and simulate out how much revenue, right? If this happens, right, then it's this price. If this happens. But don't you think inherently, if you know the device itself, right? Because we don't know what's behind the meter. If we have a grid that every component has been tokenized, right? And we know what it has potential of doing, and that we can assign a smart contract that says, what if scenarios, right? What if this happens, right? This gets paid, or what if, right? And that way it is, you know that everything is being fair, right? That who are getting paid is really, this actually happened, right? And these people got paid, but yeah, we didn't have sun for 2 weeks, right? So nobody's getting paid. I don't know, but you know what I'm saying? It's like,
yeah, I understand. Actually, those are the difficulties that we're encountering, because we're doing several projects with local utilities just to quantify their demand response baselines, because they have called the devices in response to their signals. And then they want to see if we can actually quantify, if these people won't take action, what would be the baseline? So then they can quantify exactly how much when they reacted, the reduction would have been. And then there's another question. If we have this much reduction, how much is due to each device? Because they probably have 5,000 HVAC out there to take action. And then they only have a signal sending out, but they don't really have the sensor that could actually receive the information back. So this means that each piece of device, if they want to have a two-level, like a two-way communication, then they would have to establish a network with additional money to that. If your token can consider that, then probably it could be allocated. But the problem is the benefit may not be big enough to offset the cost. So I think those are the ones that eventually you probably need to use some big data analytics just to settle with an estimation. And then that estimation could bring you an error within the limits that your cost could warrant, right? So you don't have to say, hey, I have 9 cents and then this guy contributed and it's 8 cents. Maybe we just pay them at 9 cents overall to save the trouble, right? So those are just my comments.
Yeah, this is fascinating. I think we are all moving in the same direction. You mentioned, I think we are almost running out of time. Just to mention one more thing, several times, Pamela, you refer to aggregators. Some of the things, Ning, that you are worried about, what the individual think is doing. Do we have to have smart meter on every component? Maybe gets overcome by just saying, I have neighborhood aggregator and there is trust, there is cooperation at the neighborhood level. So this is how, you know, how people win, right?
Yes.
And so I found what Pamela was talking about, and we've been interacting now for quite some time, really fascinating, because we see that the things are going in that direction. You know, all these components are getting Internet of Things and everything, but there is no the integrating framework to put it together to work. And so I very much appreciate, Pamela, you talking with us, and Ning is going to give a talk next semester. So so
I will connect up. Thank you.
I make sure that people see but we very much appreciate, and I honestly think let's go a little bit more through time and see, but I think there are some really fundamental research questions. You know, you can't just take these or just take my model or just go and find the baseline and be done.
Right.
So, but these are exciting times. Very much appreciate, and happy holidays to everybody. You are the last this semester, Pamela.
Thank you, Maria. And thank you, Dan, for organizing this. And everyone, please connect up. I'm happy to connect up with you on LinkedIn. I'm always looking to work with the best and the brightest. And
so we can share, we are allowed to share your talk. It's going to be on YouTube, right?
Yeah, I think so. Yeah.
Okay, so I mean, we are allowed to share. You give us permission. I think that a lot of people were, I don't know, either something happened with the link this morning or people, it's just holidays, but we will make sure to upload it, and I'm sure you'll hear from other people.
Okay, great.
Thank you.
Thank you again. Happy holidays. Thanks, everyone.
Bye-bye.
Thank you. Bye.
Thanks. Bye.